everyone, welcome to Limits. In today's video, we are going to talk about what limits are and how we can apply it and solve for the limits. Now, limits is very important in mathematics, especially in calculus. And so, with various examples today, we are going to touch on limits. So, first of all, what even is a limit? So a limit essentially is we have in a graph, we have an x value that we are approaching. So here we have x arrow c. Now you could just call c as a number. And so what this basically means is that as x approaches c, the graph will approach L. So essentially L is the value, the y value, that f of x approaches as x approaches c. So let's say I have a graph here, a linear line here, and let's say we have a point at 2, 3, for example. And so if I say, okay, what is the limit, and this line, by the way, is called f of x. What is the limit of f of x as x approaches 2? So as x approaches 2, well, the y value will be 3. So the graph approaches 3. And so although this is a very simple example, it is an essential one to understand because it means when x is approaching something, then L is the y value that the graph gets closer to. So let's try an example. We can solve it through graphically and algebraically. So first of all, graphically, we can try doing that. Okay, so for question A, we have limit of f of x. So just to be clear, this is f here, this is g, this is h of x, and this is j of x. So it is asking for the limit of f of x as x approaches 2. So first of all, when it comes to solving the limit, we want to first identify where x is. So x is 2. And now remember, as the graph approaches 2, where is the y value? So notice how, unlike the linear function where we only have one point, we can see there are 2 points. And although a point here, you can see it is open circle, it is undefined. When it comes to limits, we will still write that value because it is approaching that value even though that value does not exist. So here, what do? We have 2 values. When x approaches 2, it could either be 1 or 0. So what should it be? In this case, it would be does not exist because there are 2 values. Now, on the other hand, if I say x approaches 2 from the right, the positive sign here represents that it is approaching from the right. Then I know approaching from the right, then it would be 1. Whereas if I say if x approaches 2 from the left with the negative sign, it will approach 0 because it's approaching from the left. But in this case, it doesn't specify, so it does not exist. Let's look at another one. We have limit of g of x, so here on this graph. And it says as x approaches 2 again, there are 2 points here, so it does not exist. Because approaching from the left, we get 1. Approaching from the right, we get 0. That's 2 different values. Moving on to h of x. Now here we have an equation instead of a graph. So when it comes to an equation, does that mean we have to graph it? Well, no, we can also do it just by simplifying the equation. So we could expand this and we can get something like this, x minus 2. And so here we can cancel out x minus 2. And remember, when we have 2 values in the numerator and denominator, and when we cancel out, there is a whole. And so we have here as x approaches 2, when we have an equation like this, we just substitute the x value. So here we cancel out those 2, and so we plot x as 2, we get 2 plus 2, which is 4. So here the value would be 4. On the other hand, we have a piecewise function. So here it says when x approaches 2. Now here, a piecewise function, instead of graphing it, we can see the domain. So from the left, the value will be 1, and from the right, the value will be 0. So that again, that's two different values. So it would be does not exist. Again, if I try making it a positive sign here, meaning that as x approaches from the right, then we know x has to be greater than 2 because it's approaching from the right, then the value will be 0. On the other hand, if it's negative sign, then x approaches 2 from the left, where x is less than 2, then the value will be 1. In this case, again, it does not specify, so it does not exist. So let's do a few more practice. Let's try algebraic method. Now when we do this, similar to what we did earlier, we also want to simplify it. Or we could also just substitute in the value and then solve it from there on. So we have as x approaches -1. So I can just simply plot x as -1. -1 squared minus 4 over -1 squared plus -1 minus 12. So -1 times -1 is just 1. And then we have 1 minus 1 minus 12. So 1 minus 1 is just 0, so we have -12, and 1 minus 4 is -3. So our final answer would be 1 over 4. Now, let's look at another piecewise function. So here, it says the limit as x approaches 2 from the left, because it has a negative sign. So from the left, we want to look at, okay, so this is a piecewise function. We see that the x value here all have something at 2. And we should choose, in this case, it would be x is less than 2 because it approaches from the left. And so it has to be less than 2. So we only focus on the first equation, and we don't need to care about the rest of the equation. So 3x minus 7. I want to substitute 2 into x, so I get 3 times 2 minus 7 equals to 6 minus 7, which is -1. And now, last but not least, we're going to try solving this, another one, a rather more difficult one with square root. So here, just like earlier, we talked about substitution and how, as for example here in this case, as h approaches 0, can we just plot it in? Well, not really, because if you look at it, if we plot h as 0, we would get an undefined value because denominator can never be 0, otherwise it would be undefined. So we don't want an undefined value. So what we can do is we can simplify it, but how do we simplify? We have square root. So in order to simplify with a square root, we want to get rid of that square root. And how do we get rid of the square root? By multiplying another square root of it. So we have square root of h plus 9. So I want to do square root of h plus 9 plus 3 so that it cancels out nicely. And if I do that, I also have to do it down in the denominator, which is just 1. So we can simplify it by multiplying this whole thing so that we can cancel out the square root. So here, h plus 9 square root and times square root of h plus 9, well, we can cancel out, which is just h plus 9. And then we're left with, because -3 times square root of h plus 9 and plus 3 times square root of h plus 9 cancels out nicely. Therefore, we only end up with -3 times 3, which is -9. And now we want to just put everything in the denominator without expanding it. And we want to cancel out the 9 here, so we just get h. And again, we have h and h here, so we can cancel that again. and we got into square root h plus 9 plus 3. So now what we can do is we can finally substitute h as 0 without getting an undefined value. So let's try that. 1 over 0 plus 9 plus 3, and luckily we get square root 9 plus 3, and it turns out nicely, which is 3 plus 3, which is 1 over 6. So that's our final answer, as the limit of square root h plus 9 minus 3 divided by h, as the h value approaches 0, the y value goes to 1 over 6. So that's the end of our video. Just a summary of limits. We can solve it through graphically and algebraically. And when we have a positive or negative sign here, positive means it approaches from the right and negative means approaches from the left. Thank you everyone for watching. I hope you all enjoyed the video.